is a language that I'm using to communicate to you, and you're able to understand what I'm trying to tell you through English, right? Because English has its own words, it has its own sentences, and this sentence conveys a meaning to you, right? In the same way, math is also a language. It has its own symbols, it has its own operators, it has its own language that it communicates to you. And once you're able to understand this particular language, you'll be able to appreciate what maths is. And algebra brings in some unknown to that particular language. And that is what makes math all that more exciting and interesting. And to simplify algebra, what I will actually be doing is to actually help you understand where algebra comes in through this particular story. I'm pretty sure you know this particular story, right? You are able to recognize that story. That's Arabian Nights. The guy who's basically standing like that, that's Aladdin. That's the hero of that particular story. Aladdin, well, he used to live with his monkey. The name of the monkey was Abu, and he was a brave guy. He was an intelligent kid, and he was a very, very adventurous as well. He used to go out on different kinds of adventures, and in one of such adventures that he went into a cave. And in that cave, he finds a magic lamp. He rubs that magic lamp and poof comes a genie. And that's the genie that you basically see there. And that genie who comes out of that magic lamp says, "Your wish is my command." That is, he grants him 3 wishes and he says, whatever those 3 wishes are, I will effectively help you get those wishes, right? And then Aladdin does not use all his wishes and the story continues. Aladdin one fine day falls in love with the Princess Jasmine. He looks at her. As soon as he looks at her, he falls in love. Love at first sight with that particular princess. And now because he sees that princess, now he calls back Genie and says, "You know what, Genie? I want to become a prince so that I can marry that princess." And now the story actually continues because the story needs to have a villain, right? And the villain actually happens to be a sorcerer who actually goes and captures Jasmine. Aladdin, being a brave kid that he was, he actually goes and defeats this sorcerer and rescues Jasmine. And in this entire process, he also frees his genie friend from the lamp. And then finally, Aladdin marries Jasmine, and Aladdin, Jasmine, Abu the monkey, and Genie live happily ever after. That's the story. Now, why did I use that particular story? Because through that entire story, I just want to take one segment of that story. A segment where actually Aladdin goes to a market to buy some carpet to impress his lady love. And through that carpet buying story, I will also introduce some math, some arithmetic, some algebra, some unknown, so that you're able to understand how algebra comes into being, right? So I've got 3 versions of this particular story. Just follow the versions. The story is the same. There are very, very small few things that I'm changing as far as the math is concerned. So just understand the story for the first time. On the other 2 versions, I will just tell you what are the changes that I'm making. Why am I making those changes? Because I want you to understand how algebra comes into this world, right? Very, very simple. So now let's read this story. Aladdin has 5 gold coins. He's got 5 gold coins. He went to the market with Abu to buy a carpet for his lady love. Since Abu was hungry, Aladdin bought bananas worth 2 gold coins. Now, Aladdin didn't have enough gold coins to buy the carpet. So the genie that was with him magically tripled the number of gold coins that Aladdin had. So he had 5, he spent 2, and whatever was left with him, the genie tripled the number of gold coins. And then Aladdin went and bought the carpet that he wanted to buy by using 6 gold coins. So now the question asks us, how many gold coins did Aladdin have at the end? That is the question, right? Now let's actually try and putting this in words, and I will help you, or whatever is in words, in numbers, and I will help you understand how algebra comes into this entire picture as well. Aladdin has 5 gold coins, so he has got 5 gold coins, and he spends 2 gold coins. Because he buys bananas, he spends 2 gold coins. When you say you spend, what do you have to do? You have 5, you spend 2, effectively means you end up with 3. What did you do? What operation did you do? I'm pretty sure all of you know. I can even hear you saying subtraction, right? Because 5 minus 2 is what you basically do to find out the total number of gold coins that are there. And now I end up with the answer. The answer is basically a 3. So now what does Genie do? because he figures out that he did not know he could not buy the carpet with the number of gold coins that he had. He goes to the genie, and the genie triples it, and triples it effectively means multiplies it with 3. So when the genie triples it, what is the number of gold coins that he'll be left with? He had 3 gold coins. Now he's left with 9 gold coins, right? That is how much he's left with. Now he goes and buys the buys the carpet for 6 gold coins, which effectively means when he buys, he spends it up, he gives it away, that is a -6. And how much does he end up with? He ends up with 3 gold coins, right? That is the statement. So now, if you actually take a look at it, right, this is about 60 words or so, or probably even higher. This 60-word question that was there, the 60-word puzzle that was there, the 60-word challenge that was there, got converted into this nice and beautiful one-line statement. And that is why the language of mathematics is so much more impressive than the language of English for me, right? Why? Because anything that is there, which I can communicate using words and sentences, I can write it in a short, sweet, and nice way as far as mathematics is concerned. So math as a language is a sweet and short language. That is why it is so impressive. This sweet and short language, how can people not fall in love with? That is why I'm in love with this particular language. I'm pretty sure all of you are also going to be in love with this particular short and sweet language, right? So now, getting back to the maths that we were talking about. So in this particular thing, there was an LHS, that is the left-hand side of the equation, something that you've already learned in your previous grade as well. And then there is the RHS. So as far as this question is concerned, this was the unknown. You knew the mathematical operators that you were supposed to use because of the word problem. You used the word problem. You converted the word problem into a mathematical statement by using mathematical operators, by using the symbols and the mathematical operators. And when you did that, you formed all of this on the left-hand side, and then you found out something on the right-hand side. And that is what you did in arithmetic. But now, let me just go to the second version of the story. Literally the same set of things that was there, but I've changed 1 or 2 things, right? In this version, I knew how many gold coins Aladdin started off with. That was in version 1. I knew how many he started off with. But in version 2, let's make this imagination, right? He did not know how many gold coins he started off with in the morning. He had some gold coins in his pocket. That's all that we know of. He had some gold coins in his pocket, and he walked into the market, and the same set of operations happened. That is, the same set of transactions happened. He went into the market. He spent, he did not know how many, but he spent 2 gold coins to buy those bananas. And then he figured out that he did not have enough. The genie came and tripled the number of gold coins, and he bought the carpet with 6 gold coins, and he finally ended up with 3 gold coins. Out here, in this version, you did not know how many he ended up with, but you calculated it. You came to the answer that it was 3. But this was something that you did not know. But here, what is happening is that in the question itself, they told you that he ended up with 3 gold coins. But what he started off with was the unknown. You do not know how many he started off with, but you basically ended up with 3 gold coins. When a situation like this comes, because you knew what it was, and I have just changed, instead of 5 gold coins, I basically said he had an unknown number of gold coins. You know that this unknown is actually 5. You know that this unknown that I'm talking about has 5 behind it, because you already know, or you've calculated it using arithmetic, right? So now, what happens if I actually change a few more things? What happens if he actually starts off with the unknown number of gold coins, but now instead of spending 2, he starts spending 3 gold coins? So, and then what happens if the genie now triples it, and instead of buying the carpet for 6 gold coins, he buys it for 9 gold coins, and he is left with 6 gold coins. He started off with an unknown number of gold coins, but he ends up with 6 gold coins. That if you were to be given such a puzzle, how would you solve it? you know what? You will actually be able to solve it if you have the power of algebra. And that is what we will effectively be entering into today. The power of algebra, the power of knowing the unknown. And that is what we will actually be addressing today. In fact, let's hold on to these three versions of the story. I will come back towards the end of the class and help you understand and solve this. But what did you understand from all of this? You understood that math is a kind of a riddle, right? Something that you don't know, that you are given some small hints. With these small hints, you have to find that something that you don't know, right? That is what it effectively is. So now math is actually a puzzle. Algebra is actually a puzzle, and all of us love solving puzzles, right? So that is what we will actually be doing in today's class as well. Let's park this particular example for now. I will actually give you another riddle, another math riddle. Just understand this math riddle and let's both solve it together. I've got two digits. It's a two-digit number. The first one more than the second. The first one more than the second. Together, they make half of 10. Who am I? This particular puzzle, I'll just repeat it once more, or this particular riddle, I'll repeat it once more. I've got two digits. First one more than the second. Together, they make half of 10. Who am I? So this riddle has got three statements, and they're asking you guess that particular number. It is a nice little puzzle, a nice little riddle to solve, right? I've got two digits. You know that it is a two-digit number. 12 is a two-digit number. 99 is a two-digit number. 34 is a two-digit number, and so on. The first one is more than the second one. That is, if you choose your first digit, let's say you choose it as 6, the second one has to be 1 lesser than 6, because the first one is 1 more than the second, which effectively means if the first one is 6, the second one has to be 5. If the first one is 8, the second one has to be a 7. The first one is a 2, the second one has to be a 1, right? That's what the second condition is talking to you about. These are conditions that are given to you. Two digits. First one is greater than the second by one number, and together they make half of 10. That is when you add them together. That is what is the language of mathematics. Together in mathematics basically means you add them. So now if you take these two numbers, if you were to say, let's say you were to take 35, if you were to add them together, the sum of those two numbers is effectively 35, 3 plus 5 is going to be 8. But in this particular question, what they're saying is together they make half of 10. What is half of 10? You know that the half of 10 is a value of 5, right? So it is a two-digit number. I know that it is a two-digit number. What is the first digit? The first digit is something greater by 1. And when I add both of these digits, it has to give me a value of 5. So now you know how you could guess this number, right? I'm pretty sure you've already guessed it. Most of you have already guessed it. What is the number? I can hear you say it. It is going to be 32, right? Why 32? Because 32 satisfies all of the conditions that have been given out here. What are the conditions? I've got two digits. Yes, I've got two digits. The first one is 1 more than the second. 3 is 1 more than 2. Together they make half of 10. That is 3 plus 2 is half of 10, which is a 5. So who am I? I am 32, right? It was a nice little math riddle. What were you trying to do out here? You were trying to guess a number. The number, when you started off with, was an unknown. You did not know what that number was. Now, you had both of these unknowns, or something that you did not know, something that was covering the 32. You kept both of this in mind. Now, you started to unravel this. You started to basically pick out the questions, what they have basically given you, and try fitting in if these two numbers actually satisfy every part of that particular question. And when you did that, you ended up with a 32. That is what you did. What did you do? You had an unknown and you slowly started to unravel this unknown and find the answer. And that is exactly what algebra is all about, right? Algebra is all about solving math riddles. In the world of algebra, there is something else apart from numbers and mathematical operators. There is some unknown that is there in this world of algebra, and understanding or unraveling or opening out and figuring out what that unknown is what we will actually be doing in all of algebra. And like I told you, algebra is a lot like arithmetic. It is exactly like arithmetic, but with this unknown that basically comes along with it, right? So in arithmetic, if you are given this particular statement, 4 added to 3, you know how to do it, right? You know that added to in the language of mathematics is to basically use this particular symbol. Added to corresponds to this particular symbol. You already know that. Whenever people say added to, you'll just basically put this plus sign there. So 4 added to 3 is 4 plus 3. In the same way, when it comes to algebra, a number added to 3, you don't know what this number is. It is just a mystery that is there till you solve that puzzle, right? So a number, which effectively means I don't know what this number is. It is an unknown. So I can represent that unknown using this particular box, for instance. I can just say box plus 3 is the statement that is equivalent to this particular statement that I make. 4 added to 3 can also be thought of as a box added to 3 in algebra. Maybe the box is hiding something. The box that is there, maybe it is hiding a 4. Maybe it is hiding something else. I don't know till I basically go and solve this particular question. But box is that mystery box that is there. And that mystery is all about algebra. So now, instead of that particular statement, right, a number added to 3, if I were to change that statement and say 2 numbers added, right? How do I represent it in algebra? Maybe I will think about it as a square plus a triangle, right? Because there is a square hiding something. There's a triangle that is also hiding something. Both of these are hiding something. Maybe it is hiding a 4 and a 3. Maybe it is not. But if it were in arithmetic, they would have already told you what those numbers are. But when it comes to algebra, they try to make it mysterious. They try to make it like the story that I was talking to you about. Very, very mysterious, right? Once they make it into a mysterious story, now it is your challenge to actually go and unravel this, to go and unhide the squares and the triangles and find out. So now, as far as the language itself is concerned, right, instead of writing squares and triangles and circles and so on and so forth, it becomes very, very complicated. Think about it. If there are like 5 numbers or shapes that you have to think about, becomes very difficult to communicate, right? Maybe you'll write a square, then a triangle, then a rectangle, and then a diamond, and then a star. How many such shapes can you think about? Instead of thinking about it as shapes, can I use something that I already know of? I can use the English alphabets. I can use the English letters to actually communicate things that I don't know, right? And that is exactly what we do in algebra. We start using the letters of the English alphabets to actually communicate things that we don't know of. A number added to 3. When somebody tells a number, I don't know what this number is. This mystery that is there, I don't know what that mysterious number is. So when I don't know, I represent it by X, right? I can represent it by Y, or I can represent it by any other alphabet, or I can represent it by any other letter in the alphabets. So that's why you can see that the X has a hat, it has goggles. It's acting like a detective because it is mysterious. It is hiding something behind it. You don't know what it is hiding behind, right? So in this question, a number added to 3, I can effectively write it as X plus 3. In the same way, how I wrote as 4 plus 3. When I said 4 added to 3, I wrote it as 4 plus 3. That is exactly what you did when arithmetic is concerned. But now, when you're talking about algebra, you have this mysterious letter X that basically pops up, and that becomes X plus 3. So now, in algebra, if they were to say 2 numbers are added, 2 numbers, 2 different numbers, right? That is what you basically understand. When 2 numbers are added. When they said 4 added to 3, it was 4 and 3 were 2 different numbers. So you represented 4 differently from representing 3, right? In the same way, when you have to represent 2 different numbers, you start picking 2 different letters in the English alphabet. So you will basically write it as X plus Y. Why X plus Y? You already understand it because you don't know what that number is. till the point that you go and solve that mystery. You don't know what that number is. Therefore, I'll basically write it as x plus y. So now, what have we learned till now? Let me just recap it, and I will also introduce one new term called an expression for you. What was 4 plus 3? How would you write something like this? This is the arithmetic way of writing it. So, I'm just not talking because I want you to figure out what I'm writing out there. This way of communicating to the world is 4 plus 3. What I've written out there is an arithmetic expression. So a number added to 3, I can write it as x plus 3 when I use the letters of the English alphabet to communicate a mathematical statement, right? I call it an algebraic expression. This is what I call it. Whenever I use the alphabets, instead, I don't know the number, it is a history, it is a mysterious number that is basically hidden behind. Whenever I do something like that, this particular statement is what I call as an algebraic expression. In the same way, if I were to use just numbers, I call that statement an arithmetic expression. But both of it is actually expressions. So now if you ask me what are expressions like, you see those kids out there, one kid is crying, one kid is sad, another kid is angry, or the same kid is showcasing his expressions. What are those expressions actually trying to tell you? They're trying to communicate a feeling, right? It is trying to communicate something. The expression in the word, in the English language is trying to communicate something to you. Here the kid is trying to communicate that he's sad or angry or happy or whatever. The expression, as soon as you take a look at it, you're able to say what that kid is. In the same way, if math has to communicate to the rest of the world, it uses expressions to communicate. It could either use an arithmetic expression, which is what was something like this, 4 plus 3. What is 4 plus 3 trying to tell you? That whatever is there is a value of 7. That is what it is trying to tell you. When it comes to algebra, x plus 3, I don't know what that x is. I have to add a 3 to that particular number that I don't know. That is what the algebraic expression is trying to communicate to you. In the same way, just like expressions, your facial expressions communicate certain things, algebraic expressions or arithmetic expressions, in fact, expressions try communicating to the rest of the world certain things, right? So whenever I write a mathematical statement, what I'm actually trying to write is an expression at the first stage. That is what I'm basically trying to write. And like I told you, algebra is a lot like arithmetic. It is very, very, very much like arithmetic itself. So if in arithmetic, if you were to write 3 plus 2, in algebra, because there are two things that I don't know, these are things that that is not known to me, I will start using the letters of the English alphabet and I will write it as a plus b. I will maybe find out what a is hiding and b is hiding a little later on. But when I were to write this particular expression, I will write it as a plus b. In the same way, if I were to subtract, I will write 3 minus 2 in arithmetic. I could write the thing as a minus b, a what it is hiding and b what it is hiding, we will try finding out later. And when it comes to multiplication and division as well, it is the same thing. But multiplication as such is slightly special. And in fact, even division and multiplication, it is slightly special because the way in which we write this is, as far as algebra is concerned, is slightly different, right? Why do I say that it is different? Because as far as multiplication is concerned, it is the default operator as far as algebra is concerned, right? What do I mean by a default operator? When I say default operator, what I mean is you don't necessarily need to write that symbol, that cross symbol that is there. You don't necessarily need to write it when it comes to algebra, because people or mathematicians all around the world understand that when you don't write that multiplication symbol also, it is by default implied. By default, it is what it is, and you don't necessarily need to write it. What do I mean by that? When I have to multiply A and B, right? When I have to do something like that, or I have to multiply 2 and D, I don't necessarily need to write that multiplication symbol in between these, between out here. As you can see here, you can just basically write it as A, B put together. What it means to mathematicians all around the world is that you're trying to multiply A and B. That is what it means. If you were to multiply two numbers, you had to put them together, right? Why? If you were to multiply, let's say 2 and 5, you always had to put this symbol in between. Why? Because otherwise people could have got confused by 25. Are you saying 25 or are you saying 2 times 5? Basically trying to communicate. So once you appreciate the language of mathematics, you'll be able to appreciate or understand how math is communicating to you. In the language of mathematics, in the language of algebra, when you're using algebra,